problems together from the math book today. So let's start with this one. This 3a equals 12. So question from the video yesterday is what are we doing to the variable? What are we doing to the variable? So we're timesing the variable by 3. So if we want to cancel that out, if we want to get rid of timesing by 3, we would need to divide by 3. And again, we're going to do it to both sides. So these cancel out. And then I'm left with a equals 3 divided by 12 is 4. Okay. All right. Let's see. Let's look at this one. So we've got s over 10 equals 70. So what are we doing to the variable? So this line again means division. So that means we're timesing. We could actually rewrite this equation if we wanted to say s divided by 10 equals 70. So what's the opposite or the inverse of dividing by 10? It's multiplying by 10. So we're going to do that to both sides. Sorry, 7. S divided by 10 equals 7. So we multiply both sides by 10. Those cancel out. And we're left with s on the left side. And then 7 times 10 equals 70. Okay. All right, let's try a little bit harder. Let's try a little bit more difficult one here. So let's do this one. All right, so we've got 24 equals 3r over 4. So again, we're going to ask the question, what are we doing to the 3 or to the r? So what we're doing to the r is we're multiplying it by 3. So I've got 24 equals 3r divided by 4. Okay, so so I could rewrite that. I don't have to, but I could rewrite it to be 24 equals 3 times r divided by 4. Okay, so what am I going to do first? I've got r times 3 and I've got r divided by 4. So what am I going to try and get rid of first? So from 2 lessons ago, when we were dealing with addition and subtraction, I said to always try and get rid of those first. Technically, you can do any of the steps first, but with addition and subtraction, it's easier. It's going to be easier in the long run to try and get rid of those first. Here, I don't have any addition or subtraction, so it actually doesn't matter which number I try to get rid of first, because we're going to get the same answer, and it's going to take about the same amount of time. So on this one, I'm going to choose to times by 4 first. Okay, so I've decided to times by 4. So these cancel each other out, and I'm left with 3 times r on the right side. And then 20 times 4, let's see, what is that, 96? So now I've got 3 times r equals 96. Okay. Let me just double check that. 480, 16 to 96. All right, so now to get rid of the r times 3, I'm going to divide by 3. I'm going to divide both sides by 3. So now I'm left with r equals, let's see, 32. Okay. So let's look at what would happen. Let's look at what would happen if we did, instead of dividing or timesing by 4 first, if we divided by 3 first. So I would get 24 divided by 3 equals 8. And then these cancel each other out. So I'm left with r divided by 4. So now I'm going to times to get rid of the 4. And on this side, these cancel out with r. And then 8 times 4 is 32. So I'm going to get the same answer either way. Again, when you have addition and subtraction in the equations, you want to try and get rid of those first, because otherwise it's going to make your problem look funky if you try to do the multiplication or division first. But if you just have multiplication and division, really doesn't matter. It's going to take you about the same amount of time, and you're going to get the same answer. All right, let's look at one more of these kind. Just change my pictures here. Let's look at this one. So this is one of the error analysis from the math book, and we have obviously there's a red X there, so that means they did something wrong. So X does not actually equal 7. So let's look and see what they did. And if you remember from class, me telling you the best way that I know how, a lot of times we'll look at these and we'll say, well, I have no idea what they did, right? I'm looking at it and I'm like, I don't have any idea what they did. It seems overwhelming to try to figure it out. The best strategy that I use, that I've found, for me anyway, and that I've seen works for students, is to do it the way you think it's supposed to be done first. So do it the correct way first. So in other words, if we had X divided by 4 equals 28, okay, and I'm going to change that too, so we can see it a little better. So X divided by 4 equals 28. What would we do, or what are we doing to the X? And what do we do to get it all by itself? So we're going to multiply by 4, and I'm actually not going to use, I'm going to use this multiplication symbol because I've got an X in here already, and that's going to be confusing. So I'm going to multiply by 4, multiply by 4. So now these cancel each other out. I've got X on this side. And let's see, 4 times 8 is 32. 8, 9, 10, 11. So I've got X equals 112. So that's how I would do the problem. Now that I have something to compare it to, I'm going to go back and look and see what they did. So here we have X divided by 4 equals 28. So in this next step, so this is step 1, step 2, they had X divided by 4 divided by 4 equals 28 divided by 4. So in our step 2, what did we do? We timesed by 4. They divided by 4. So were they right or were we right? Well, we already know that they were wrong. Okay, but if we didn't know that, let's look at if dividing by 4 makes sense. If we want to get X by itself, what would we do to get X by itself? We would multiply by 4, not divide by 4. So the error that they made was they should have multiplied by 4 instead of dividing by 4. And when they multiply by 4, the correct answer that we get is x equals 112. Okay, I hope that one made sense. Let's look at some word problems. Let's see, 45 basketball players participate in a tournament. Write and solve an equation to find the number of 3-person teams they can form. So we're actually going to write an equation to match this problem. So we've got 45 basketball players, so we know we're going to have a 45 in there somewhere. And then we want to know how many 3-person teams they can form. So we don't know how many 3-person teams they can form. We don't know. So what do we use for an unknown amount? We use a variable. And I'm actually going to label each one of these things so I know how they relate to each other. So 45 total participants. Okay, so I've got 45 total participants. I'm going to say n, actually I'm going to use t, number of 3-person teams. And then I have my 3, and that is number of people in a team. So I've got the number of 3-person teams. I've got 45 basketball players, and I have the number of people in each team. So how am I going to take these? How am I now going to take these and put them in an equation that matches these relationships? So 45 total participants. Well, I'm going to use that and say, when a total is usually what comes after an equal sign. So 45, I'm going to say something equals 45, right? Then I'm looking at the number of 3-person teams, and I want to know how many of those there are. I want to know how many of T there are. So I've got, and I know that there's 3 people on each team. Okay, so that means however many teams there are, I'm going to times that by 3, and that's going to give me the total number of people. So now I have my equation that I can now solve. So I've got 3t equals 45. 3 times t equals 45. So what are we doing to the variable? We're timesing it by 3. So to get rid of it, we're going to divide by 3. These are going to cancel out. I'm going to be left with t, and 45 divided by 3 equals 15. So does that make sense for my problem? Well, if I have 45 basketball players and they're on 3-person teams, I would divide 45 by 3, and that would give me the total number of teams that I could have. So that works. All right, so let's look at another word